Welcome back, everyone. We are starting our Science Week 10. So let's take a quick look where it says Science Week 10. There it is. All right, Science Week 10. Now, let's start with reviewing our quizzes. That's right here. So, the first question was, what are the components of this jacket? Now, if you remember, the old jacket had buttons, but does this jacket have buttons? No. So A is wrong. How about plastic and zippers? Do you make a jacket out of plastic? No. So that one's wrong. How about plastic and buttons? Well, there's no buttons, so that's wrong. And finally, fabric and zippers. Ding, ding, ding. There we go. That's the right answer. Now, this question is asking, what are the materials? So, the components might be a metal sheet, wooden rods, nails. But what is the fence made out of? What are the materials of the fence? The materials are ceramic? No. Plastic? No. Plastic? No. Wood and metal. Ding, ding, ding. Next, we have this juice. What are the components? What is this made of? Well, there is wood? No. Metal? No. Is there plastic? No, they don't have a lid here, so it's not plastic. So we have paper and juice. And then we have some questions about what happens in the sun. So we have sun, a nice hot sun, and we have chocolate. What happens? That's right, it melts. And how about a popsicle or an ice pop or ice cream? What happens in a hot sun? That's right, it melts. A jacket? Does a jacket melt? No, of course not. And now we have the freezer. What happens if we put alcohol gel in the freezer? Alcohol gel looks like water, right? But it's not. It's very, very different from water. If we put it in the freezer, it will do nothing. You can try it at home. Put your alcohol gel in the freezer, and it will still be alcohol gel. Because water freezes at 0 degrees, and alcohol freezes below 100 degrees. So it's minus 100. Okay. Next we have what happens in the freezer. All right, so you can go to your kitchen and you can try this also. You can take your table and you can put it in the freezer because I think it will fit. And then you can see nothing happens to the table. I'm kidding. A table is too big to put in the freezer, right? Next we have some juice. Is juice the same as water? I don't know. What happens in the freezer if you put juice? Well, the answer is it freezes. But isn't juice different from water? A little bit, but juice is like 90% H2O. And that's what water is made of. Now, last question. How does water change when it becomes ice? So how does the water change? So we have water. And then we have ice. So what happened to the water? So this is a glass of water, and then it became this block of ice. Did it get warmer? No. Did it get smaller? No. It is bigger. When water becomes frozen, it gets bigger. All right, let's start our new unit, which is about forces and motion. So everyone should look at this page now. And we see a bunch of kids here, and this student says, what? Oops, that's not the good color. What are the students doing? So let's take a quick look. Well, we have this student right here. He's playing with a magnet. So that's called a magnet. Let's type that down. Ready? Magnet. A magnet attracts metals. So you can pull the metal to the magnet. Okay, so that's pretty cool. And what about this student? This student is being pushed in a chair. So she's going in a roller chair really fast, and she's sliding along because it's on wheels. But how did she move? Well, this student pushed her. So in this picture, we have something pulling. The magnet is pulling, and this boy is pushing. Now we have an important word here. Do objects move when forces act on them? How? Well, first I think we need to know what this word means, forces. So let's quickly learn that word. Well, force is short for forces. What is a force? A force is something that causes pressure on another object. What is pressure? Well, I'll explain. Pressure is, like we said before, something that pushes or pulls on another object. Well, let's see what that means. In this picture, we have pull. This picture is pull. This student is pulling this student. That is one force. And the other force is, that's right, it's push. So this force pushes the object. So this student pushes the other student. So forces are basically pulls and pushes. Let's see if we can understand that a bit more when we talk about the car on page 75. And you can see how important forces are. They say forces a lot in this page. It moves when a force acts on it. How do forces make objects move? All right, so let's talk about the vocabulary first. The forces push and pull, but let's talk about what these words mean. So we'll start with number 1. Start moving. What does it mean to start moving? Well, let's take a look. This is a car, and the car is now not moving. So the car needs a lot of power to go from 0, so the car is at 0 right now, to begin moving. So it needs a lot of force just to begin moving. And then the car can keep on going. The next car, we're going to talk about movement. Movement describes how the car moves and how far it moves. It doesn't talk about starting or stopping. It means how much the car moves. What is the movement of the car? The car is moving in a straight line. The movement, we can even measure it. The movement may be like 10 meters. So we can label this 10 meters. Okay, that's the movement of the car. The movement can go any way, any direction. Let's take a look what that looks like. So wherever the car moves is the movement. So if the car moves like this is the movement of the car. Now, let's take a look at the next word. We have change direction. So let's take a look at the changes. Well, this is the beginning direction. And now we have our first change. Change number 1, change number 2, and change number 3. So there is 1, 2, 3 changes. So there are 3 changes altogether. Let me write that down for you. There are 3 changes in direction. So direction is where the car is moving. This is one direction, this is the second direction, this is the third, and this is the fourth. Any angle can be a direction. So if we take a look at this circle, and we draw a couple lines on it, any angle that the car moves is a change in direction. Even if it's just a little bit, the direction has changed. Okay? Now, last word. We have stop moving. Our last vocabulary word is stop moving. Well, if the car stops moving, it will be moving, and then it stops right there. So what happens when it stops moving? Do you think it needs to be very powerful to go back to 0? What kind of force do we need to stop? Well, if you know about cars, you know in the tires, we have brakes. And brakes stop the wheels from moving. So the brakes stop the car. But what is stopping the tires from going forward if the wheels stop? We have a force called friction. Friction is the force where 2 things slide against each other. And if you push really, really hard, you have more friction and it's harder to move. But if you have a little bit of weight, then you have a little friction and it's easy. So because a car is heavy and rubber has a lot of friction, because this is made of rubber, then it is easier to stop a big car. So friction is another very important force. So the forces we learned today are push, pull, and friction. We will review and learn a lot more in new videos, but for now, I want you to answer the question in your quizzes: what are you curious about that moves? We will answer the questions in the next class. Are you curious about the Earth, the planets, the cars, bullet trains, things falling, like if you dropped something off of a roof, like a ball or a feather, or something like that? If you're curious about that also, tell me. So that would be things falling in air. This is going to be a free answer question, so you can say anything you want. All right, good job, guys. I will see you next class. Bye-bye.